So everybody, codes day 4, just to like get in some practice for the day. So it's like hard to count. Okay, so it's like the number of teeth on the given gear. Interesting. So the question is just like, so I'm guessing like, what's like the best way of imagining this so that actually makes sense, right? We can make it turn like once. So if it's smaller, right? If it's smaller, it turns way more easily. Right. I think it's just like fractions, probably. I guess. So, um, is it just like take fractions of consecutive numbers? But I mean, how would you like interpret the fractions, right? 'Cause, so let's say if you take like a gear that has like x teeth. So like think of it like this: like you take a gear with x teeth, and you ask yourself something like, um, if this turns once, then the gear with 2x teeth turns a half times, I guess. So if you take like a gear with like 2x teeth and you make it turn once, then if you take one with like x teeth, the next one like turns twice. So it's probably just like fractions, I guess. So you just pretend, so so I guess you can think of it like this, like you need like a mental model for the fractions. For me, fractions are a little complex, really. Like I would honestly say I don't understand fractions that well, which is just, you know, a crazy thing to say, I guess, but whatever. So if you think of it, I'll try to like outline my thinking of fractions here. So if you have something like xy, so let's say you have the gears with like this amount, so you pretend that x turns once, and then you like, you just say, if let's say like this, if x turns once, then y turns x over y times. And I'm just saying this, like I'm not necessarily like thinking about anything. It's like my thought process just comes from this example, because I know 110, so the one with like 128 turns once, then the one with 64 turns 128, so it turns this many times, right? And you can do like, it turns 2 times, which is like 128 by 64. So I'm guessing this like kind of makes sense. It's not like that clear in my mind, but I think this is what they want. So if you would actually like to make it have sense, then you'd say x turns m times, then y turns like x over y times m times. So you can make like y times m, y times x, m times x, a multiple of y. So this makes sense, right? You could do that, or you could just keep it as a fraction, right? So you have like a sequence of numbers, and you always pretend like you pretend this guy turns once, and you ask yourself how many times does this guy turn. So because if you do that, you can like prove that it's like how many times does this guy turn, right? So this guy turns x1 divided by x2 times, right? So the question is, if this guy turns once, how many times does this guy turn? And it's like x1 divided by x2, and I'm just saying that like out of my mind. I have no idea like why, but it's consistent with like their definition, I guess. So we can just do that, and then you pretend, well, if x2 turns once, then x3 turns x2 divided by x3 times, right? But in reality, it's actually like, okay, if this one turns once, then this one turns this many times. But then this one actually, so x2 actually doesn't turn once. It turns x2 over x2 times. So if you want to know like, knowing x2 turns m times, then x3 turns m3 times x2 divided by x3 times. So that's m times x2 divided by x3 times. But you know x2 turns x1 divided by x2 times. So you just do x1 divided by x2 times x2 divided by x3. Right? Let me just like write this on paper so I can see like the simplification. So you do x1 divided by x2 times x2 divided by x3 times x3 divided by x4 times x4 divided by x5 and so on. So I guess these things just simplify. So you do like the first one times like the last one. It doesn't matter. It's like a chain, and it doesn't matter how many like times you go through the chain. So yeah, I'm just guessing like this is like the logical conclusion that we arrive at. So this guy comes out to x1 divided by x3. So all you have to do is like x1 divided by xn, and this is this answers the question if x1 turns once, then xn turns x1 divided by x1 times, and you want to do 2025 times x1 divided by xn. So I guess like that's your like answer in general. So that means like this guy should be a multiple of this guy, because otherwise it doesn't make or at least it shouldn't necessarily be but 2025 times x1 should like be a multiple of this, right? Okay, so I'm guessing I should just like multiply and hope for the best. Pretty interesting. So that turns 15888 times 461 times, right? So yeah, because I'm like doing so you just now need to like give you like, so this is, so you're solving for like z. You're solving for like z times x1 divided by xn. So this is like you turn x1 z times, so this one gives you like a number of times the last one turns, and you want to make sure that so you want to take this equation and just find z such that it's like bigger than or equal to that, I guess. Turns at least that many times, right? So it's like this. So now get like the first whole number, full terms. Yeah, you want to take like the first whole number that like satisfies this. So z is real in general, but you want to take like the first number such that like z satisfies this equation and z is like a natural number. So yeah, and it's rounded up. Okay, that looks fine. Like I don't know why, but this is like sped up. Like wait, what? Like this is. I don't think you should look at this image. Oh, so this is actually like giving you like a way such that you don't have to simplify the fractions. So that's like all it really is. So like you can do like x. So like the entire thing turns x1 divided by x2 times. So you know even the gear y2 like turns x1 divided by x2 times, right? You know that y2 turns that many times. Now you ask yourself, if this whole like shaft turns once, then how many times does this thing turn, right? So by this you mean it's like, and their speed depends like here. So like if that one turns once, you're like y2, this machinery turns y2 divided by x3 times, right? So it turns this divided by this many times. So even the gear y3 turns y2 divided by x3 times. And then you just multiply like, so you like got this number from before, which is like, so the question is the one before moves once, how many times does this one move, right? So if the one before moves once, then this one moves x1 divided by x2 times. And if the one before here, if the one before moves once, this one moves y2 divided by x3 times. So Ace, you just do x1 divided by x2 times y2 divided by x3 times y3 divided by x4 times y4 divided by x5. Alright, so you could interpret those as these, I guess. Okay, so that's the day.